We're going to go through the intro kind of quickly so that we have time to do some hands-on keyboard stuff at the end. One thing you can do right now to save yourself some time later is clone this GitHub repo and run npm install if you plan on doing hands-on keyboard stuff. And that's got like the stages. We're going to do like a build together thing. But maybe you feel lazy and you just want to look at the commits in that repo. So it's a good idea to scan this QR code while it's on the screen. So yeah, what we'll do is talk a little bit about the background. We'll talk about a couple of our APIs, and then we'll do some coding and get down into the editor. So Web3 storage is the easiest way to store your data on the decentralized web. It's the easiest way to upload to IPFS, and it's the web scale way and the way that makes it fast enough for the application experience that your users are looking for. So the problem we're trying to solve is that the traditional Web 2 stack forces you to make subpar user experiences, because centralized data and identity silos set you up to have to do the sorts of things that users don't really want, but they've all been trained to deal with in Web 2. So the solution is unlocking the data layer, allowing you to have data anywhere, and by looking data up by CID, I'm sure most of y'all are familiar with IPFS and the verifiable data retrieval that it enables. We think that those properties plus the performance and scale and price that we offer make a better application platform than Web 2. So we have a handful of APIs. Today we're going to focus on W3 up, but you also get access to our high-speed gateway, W3 Link, which uses a global content delivery network. So any files or images you upload to Web3 storage are going to be delivered to your end users with the speed and latency that is best in class. So you're not making any compromises. In fact, it's giving you access to the fastest way to deal with data. And we also have the W3 name API, which is like a super fast IPNS to allow you to track mutable state and get change feeds on your objects as they're mutated. We're growing fast. Mostly just want to share this to show, early on, one of the things that triggered our growth was the NFT community decided that IPFS is the right way to store verifiable data for good reasons. And that got us a lot of early growth, but since then we've been growing across the board with all kinds of Web3 applications and Web 2 as well. So today we're going to talk about these open protocols, which is what enables us to open the data layer and give your users the ability to own their data and cooperate in owning applications. IPFS you're familiar with. It's for looking up content by content identifier. And what it means in this context is that you write apps that talk about what the data is, not where the data is. That's why the data can be anywhere. You can pull a block from whoever's got it fastest. DIDs is a web standard for device identity, and the job it does here is non-extractable key pairs. So just like in the previous talk, we think that keys should be tied to devices, and that gives you a more robust user identity. And then the last protocol on the screen is Ucan, which is relatively new, but a lot of folks in the ecosystem are using it. We had Blue Sky on the stage earlier today. They're using Ucan. Fission's here also. They're using Ucan. And what is it? It's like a JWT. What's a JWT? It's a cookie. So like back in the day, you'd have a cookie that had an identifier in a database, and you'd have to go look it up. And then some clever people figured out that if you cryptographically sign the cookie, then the server can trust that content and doesn't have to go to storage when the cookie comes in. But that opens up to replay attacks. So what UCANs are is similar, but it's not just the service that must sign it, but also the client. And that's enabled by the client having private keys on hand. And it means that if your UCAN gets copied somewhere away from you, it's not an attack vector or a security hole, because it's your private key that makes that UCAN have the ability to be invoked. So we use that as the atom of delegation, which is how you would say take an account from this device and make it show up also on this account, on this other device, or how you would allow your end users to upload to your services account instead of creating their own account. So we'll talk later and get into exercises about how you can set up like either an app paid or a user paid storage account model, as well as hybrid models. So again, what does this mean? It means you can have data anywhere. It's universally addressable. You can get that data by CID from us. You can get it from anyone else in the IPFS network. And because those CIDs are immutable, they're super fast to cache. Like I mentioned, we're in the global CDN, so data you upload to us is going to be as fast as data you put anywhere. On sort of the forward-looking side of this, with verifiable data that could be anywhere, and with the Ucan execution model, it opens the door for serverless to move from the cathedral to the bazaar. So today, if you're writing a serverless function, there's just a handful of places you'd go to execute it. But what this opens up is the ability for anyone to stand up an API that can play in the ecosystem and be serverless for your application. So we'll talk about the W3 Up API first. And this is the base API that the other clients use. So its improvement over our previous API is streaming car file generation. We'll talk more about car files in a minute. What it means for you is any size file, any complexity of directory can be uploaded in a streaming manner, and it's not going to overwhelm the client or the server. It's verifiable, deeply verifiable in the sense that the data is not just stored underneath content identifiers, but you know the content identifier before we do, so you can make sure that your data integrity is maintained through the whole pipeline. You could do things like queue up the CID you're about to upload into another system and then have that system wait for the upload to finish. And then the delegation that I talked about allows you to have all those different business models. So when you use it, it's as easy as the upload command, and that's what we're about to do if you want to go through this quick start with us. This is a more lightweight NPM install, so we didn't need to do it earlier. But yeah, if you want to do this, then you'll be set up with an account, and I'll walk you through the experience you'd have on your laptop if you did do this. So the first line installs the command line tool. W3 Up ID generates the local key pair. So it just creates the identifier, public-private key pair that's going to be used for the Ucan operations. And in the app paid model, you don't need to do the next step, right? Or rather, the user doesn't need to do the next step. They could register with your app instead of with Web3 storage. We'll get into that later. But in this model, this is going to be a lot like the user paid model. Developers standing up accounts want to own those accounts when they're doing it on the CLI. So you'll do W3 Up register, and that sends you an email. And when you click the link in the email, the register command completes. So that same API feel is what you'll get in the web UI as well as in the client, because what's happening under the hood is the register command is just awaiting for the process to finish. And in your code, you'll just sit on that await until the user clicks the link in the email, and then your app picks back up again. Once you're registered, you can run W3 Up Who Am I to see who your account information is. And then this last command, the bold one, is what you'd use all the time. Upload your, create React app build or your images, your NFT drop, or whatever it is you want to upload. So Alan's going to tell us what happens for real.
All right. So yeah, this is kind of deep dive into what happens behind the scenes. So here we go. So first up, oh yeah, that doesn't work that side. Right, you generate a kind of a key pair, which is, as you probably well know, like a public and private key, and that gets us a decentralized identity, which is super rad. And then next up, we send a Ucan invocation to register that DID with the service. We call this W3 access because it gives you access to use the service. And so this is a one-time thing per device, but once you are registered, you can build a DAG from your files or data, and a DAG You probably know some of this already, but there's a representation of your files, and it's basically small blocks that link to other blocks. And it's a tree, or more specifically, a graph. And DAG stands for Directed Acyclic Graph. And it gives us a CID or a hash of the data. And that allows anyone to verify the integrity of the data. And that means that anyone can transfer it to you. So maybe like that's 101 for you IPFS guys. But anyway, the file format that we use to actually transfer a DAG to us over HTTP is a CAR file, and CAR stands for Content Addressed Archive. So kind of like a tar, but it's a CAR. That's why there are cars on the screen right now. Because you know what cars are. But anyway, so what we do is we pack that DAG into the car, and then we split it into multiple chunks, depending on the size. It might be able to fit into one chunk, but we might need to chunk it up. Cool. And then so once we've got kind of chunks, then what we do is we ask our service where we should actually upload that data, and we get back a signed URL, and then we upload our chunks. Every chunk we ask for a signed URL, and so we can go direct to the place where it's going to live. And they go into buckets, and this can be any kind of bucket really. It doesn't have to be the same one each time. They can be like S3 buckets. They can use Cloudflare R2 buckets as well. But either way, like the service that's providing the buckets is the thing that's providing the scalability here, which is rad. It means we don't have to worry about that so much. But anyway, so once they've got into buckets, finally, our implementation of IPFS, Elastic IPFS, comes along and indexes the blocks in the car that was uploaded to the bucket. And so Elastic IPFS is our implementation that runs in the cloud. And once the blocks are indexed, they are available to the IPFS network and on IPFS HTTP gateways. So that's cool. Yeah, so finally, the final thing that needs to be done is we just send a request to register an upload as a collection of car files, which is the chunks that we send. So that's the final thing that happens. But why is this cool? Well, aside from the kind of small touch points at like access and then the signed URLs, you're basically uploading data directly to buckets, which is rad. And like I said, that scales to as much as kind of Amazon or Cloudflare can scale, so like big scale, so that helps us because we have a lot of stuff coming in, and it needs to all go in, basically. And so the really cool thing is that by using Ucans and delegation, your users can be delegated the capability to upload without ever needing to register with our service. So that's cool. Yeah, so that's how it works. Oh, it's me again, okay. W3UI, so this is a library of components for building interfaces. And if you're familiar with Tanstack, you'll feel right at home here. They're headless, so they don't actually have anything to say about how things look, but what they do is they provide idiomatic kind of components for a variety of popular frameworks. And there's also core components, so you can literally just use like native JS if you like. So here we go. Hey. So the URL is beta.ui.web3.storage, I think, if you want to go and check it out. But yeah, so the frameworks that are currently there are like React, Vue, Solid. I think we're about to support React Native and Svelte. So yeah, you build your app in your framework, and if you want to use Web3 stuff to store your users' data, then you can pick one of these off the shelf, and it integrates nicely in your app, gives you the primitives you need to be able to do that DAG creation that I was talking about, and do that car chunking and splitting. It's all kind of done for you behind the scenes. You just give it some files, it uploads them, and you get CIDs back. So super, super useful.
When we get into the hacking together part, you'll see that there's like 3 lines of code that are W3 up in this app. Yeah. It's worth noting too on this website that if you click into the components and then click into the code sandbox, you can get one running right away and like show the rest of your team the user experience and whatnot without having to do any work.
Yeah, so if you click in, there's like a really simple example, and you can toggle like the framework so you can see what it looks like in different frameworks. Okay, so there's three main components in that UI framework right now. We've got keyring, which are like tools to make authentication and Ucan delegation easy. We've got an uploader component, which, like I said, it helps with the DAG creation side of things, the car splitting and uploading, and then an uploads listing component, so which like helps you list out the CIDs of data that you previously uploaded, essentially. So pretty simple. Yeah, I said that the frameworks that we support already and the code sandbox, yeah, you pointed it out already, so we're all good.
Well, this is just a preview of what you'll do. You'll start from one of the example apps that comes with W3 UI, like the one you just saw in the code sandbox, and then we'll add a web camera to it, change it so the web camera data is getting uploaded, and then list the photos so that you get an experience like the one that happens when we click this link. So here I am. Here's Alan. I'm going to click Take Photo. There's all the old photos. The new photo's uploading right now. We're tethered through my cell phone. So when it's uploading, it'll pop up on the list. But that's the app you're going to build. So to get into it, I guess it's build time now.
Yeah, let's do it. So there's people here to help you out. If you're here to help, can you put up your hand right now? Yeah, if you need any help, then try and talk to these people. That's super rad. And so yeah, essentially we've got two main tracks for you right now. And so you can choose your own adventure. So the first one is kind of more like a backend sort of Node.js focused adventure. And so but this one is for working with Ucans and delegation. And so what you'll do is you'll use the CLI tool to delegate capability to another agent to be able to upload. And so these points that we've got here on the slide are very high level. So what I recommend you do is check out the first resource in the links there, which has a more step-by-step like information on how to do that. And then the second challenge in the Node.js track is to create a HTTP API that essentially does the same thing. So you pass it a decentralized identifier, and it will delegate capability to that identifier to do uploads, and then you can use that to actually do uploads.
And so that code is what enables you as a developer to do the app paid model. So what we wanted when we created all this is that you could have some single page app or whatever, React app, drop our components into it as a developer, have uploads working right away, and like never have to pay a bill or anything. And so that's the default flow. Your users get prompted to create Web3 storage accounts. Probably 90% of them live in the free tier forever. And you don't have to have a Web3 storage account to power your application. So that's the user-paid model. But this delegation adventure, the backend adventure, enables the app-paid model. And so in that model, what happens when you're establishing a user session, somebody wants to upload on your site, is that they would call an API on your server, sending over their UCAN delegation request to you rather than sending it to us. And then you would use your cryptographic key material to create a UCAN delegation for them and send it back, and then they can use that as part of their upload session. So that allows the account to be owned by the application instead of the user.
Cool. Okay, and so this second track, if you're a bit more front-end focused, this one's for you. And so this is using the W3 UI components that we just showed. Build a selfie app where you can capture images from your browser and upload them to web3.storage. And that's what J. Chris demoed a second ago, and is actually going to be walking through building that app on stage with you today. But yeah, check it out. Choose your challenge, choose your adventure.
And this slide should be printed out on your table, so I'm not going to leave it on the screen, but I will leave this on the screen because we brought Wi-Fi for folks who are feeling crunched. So I'll just leave that up for a couple of minutes while y'all are deciding which adventure you're doing, and then I'll kick off the front-end adventure on the screen. Question?
Yeah, do you have CID that we can use to just get the content of the repos that we need?
Oh, that's a good idea.
What about, can you bring your own keys?
Can you bring your own keys? That's a great question. So where we're at today is we've got the keys that we've got so we can proof of concept it, but we're like actively working on adding support for passkey, like Touch ID, Face ID, and I mean, I guess the guy who really knows which keys you can bring is sitting right next to you. Yeah, by default, I mean, all the keys are owned by the user. Probably the least secure key store we have right now is the CLI one. All right, we're about to not have this on the screen anymore, but if you want that information, some of the folks up here at the front will be able to provide it for you. What I've done to create this app is I just took the file upload app out of the W3UI repo, has a bunch of examples. And you don't need to go get it from that repo because if you clone to the repo from that QR code at the beginning, it's just going to be the first commit. So you can just roll back to that if you want to see it. And I'll do that again so that I start from scratch here. So. All right. So when you look inside of this React app, it's going to have app.js and content page, and that's pretty much where all of our changes are going to take place. Let's go ahead and run this before we, if you already did npm install, you'll be ahead of me here. So I'm going to create a terminal and npm install and npm start. Bigger font? All right, I'm gonna go for it. Yeah. So while that npm is installing, I'll give you a little sense of what's going on in app.js and content page. App.js is where the React providers are triggered. So it's these wrappers that essentially repaint when you're authenticated or when the uploader is ready or when we know who you are. And then the content page is rendered inside of there. I'm going to go ahead and do a quick styling change while I'm in here because I know we're going to want to take that vertical height off of the app. And aside from that, it looks like we're about halfway done with the npm install. So I'll show you how content page looks on the inside. This behavior is similar to the behavior that you would see if you were to go through the rest of this app. So this is basically what the app that I'm npm installing looks like when it's running. It'll be a screen that pops up, asks you for your email address, and then sends you an email when you register. So when that email comes in, I'll be able to click it and register. And then as soon as I do click the link, this screen will turn into the uploader screen. There we go. So I'm just verifying the account that's in that in here, and as soon as that long poll completes, now we'll have the ability to upload. How's my npm? So that's the behavior of this app, and what's happening is that it's having a React hook to bring the uploader into scope. And then it essentially just calls upload or upload file with the file that comes off the browser's form UI. And the CID is what you expect. It's what you'd use to compose a link to your upload on the gateway. So here's the HTML. It's just a file input that handles the upload submit by uploading the file. It should be pretty easy to grok. While npm install is happening, I'll just go ahead and start with some of the changes then, since we've seen what the behavior is here. Here's the running app uploading a file. This is the user experience you would get by default. So back to the content page, the first thing we'll need to do is add the camera. My npm install was running too slow, so I moved over to the repo that already has it. I'm going to check out an early commit so you can be in the same place as me. So to add the camera, we just npm install this module. It's going to need to be it's listed on the piece of paper in front of you, but this W3 UI IPFS camera. And then we can import it, use ref, and put the camera in the UI with this one-liner. So that's going to look like this. Close these old ones. All right, now I have the camera in the front-end app. I'm just going to go ahead and register my session on this localhost 3000 origin so we can get it running. So that'll require getting another email and clicking the link. So again, these emails is the user experience that your customers would get if you did the user paid model. All right, while we're waiting for that, oh, there we go. Okay, now we have the camera in the app. Let's go back to the stages of putting it together. So this is the stage where the camera has been connected to upload, and I'll show you how that code threads through. So the camera, again, is imported here, and when the photo gets taken, we pull the image data off the camera, which is just a base 64 data URI. So we need to convert the data URL to a file, and that's what this Stack Overflow code is about. You'll probably just want to copy and paste that from my repo. But essentially, it encodes the data URL back into a file. And then we take the file and we hand it to the uploader. We get the CID back, and we put the CID into a list of images on the screen. So that list of images is just an array. And at render time, we take those images and we put them on the screen in standard HTML. What that looks like here is that I can take a photo, and when it uploads and completes, it'll put the photo on the list. What we haven't implemented yet is the ability to see all the photos you took in the past. So that's going to be the next step, is adding a list of all the photos in your account to the screen. So there's one uploaded image. I'll do another one, and then I'll refresh the page, and you'll see that they're not visible. So we'll need to add some code to bring in those images, and that'll be most of the data flow completed. So now we have two images. If I refresh the page, you see that those images are not visible. So let's put them back in. And that's going to require adding uploads to the application, or adding the upload list.
The Wi-Fi slide?
Yeah.
I'll take a picture of that.
Perfect. I'm going to bring up the Wi-Fi slide again for people who want that. Sorry. There we go. Slow. All right. I rolled forward a commit in the repo, and what that's done is brought in the uploads list, which is another npm module. So you'd npm install w3ui React uploads list and bring it into content page. But then you've also got to bring the uploads list provider in to the HTML here. So it's just another wrapper around your content page. Then the way we use the uploads list is just as a React hook. And when we call it here, it returns some data, and it returns a function that you can use to refresh. and returns a couple of other data points. But we're just going to use the data and let you refresh the page instead of having a refresh built in. So the last little bit we want to do is make sure that even when there's no data, we don't crash the render by putting an empty list in there. And then the last thing is, and this is the first application I've done this, but we have a single UL with LIs at the top and then another set of LIs. And the first set are the images that you took since you refreshed the page, the new images. And the old set is all the images that were in your account before that. So let's go see how this looks. So you can see now when I refresh the page, my old images are visible. And if we upload another photo, it'll show up at the top of the list. So that's all the behavior implemented. If we see what's left to do on the application to really finish it out, it's just adding some application CSS to make it render cleaner. So that's visible in the last commit in the repo. If anybody did the front-end challenge and has questions or wants anyone to come look at your screen, now's a good time to raise your hand. And I'm going to move on to doing the back-end challenge up here too so people can see how that looks. I'm going to do the back-end challenge in 5 minutes. So there's this blog post that walks you through it, and that's where I'm going to go. So the QR code on your challenge page will take you to this blog post, and then you can just step through, past all the description, you'll get to the how-to. I already ran this one, so it should be fast. And now we can run W3 up ID. As we remember, that's how you generate your initial ID. Now we can register this account. On this machine, I've already registered my account. And now let's do an upload. In this account, I may already have uploaded a bunch of stuff. So let's see what I've already got. I have 2 uploads. I'll upload another thing. So I'm uploading an image file, and when that's done, I'll list 3 items in my account. So we'll go view this file just for fun. And while that's coming in, I'll go back to the blog post and see. So to do the backend delegation, you're going to use the profile flag on the CLI, which is just like a profile in Chrome or Firefox. It allows you to have different sets of configs so you can pretend to be different people while you're working. So I'm going to create a profile called another. And now I have a new profile. And what we're going to do is instead of registering that profile, we're going to delegate to from the regular profile. So W3 up, delegate to, boom. And now I can import my delegation. W3 up, import delegation, delegation.text, main account, -- profile, another. And now I'm giving this another profile the ability to the ability to upload to that account. So now if I run W3 up, list -- profile, another, I'm still going to get an empty list because I haven't told this profile to use that account yet. So we're going to select the other account. With W3 up, delegate switch. So now, if I list the files from my another profile, we'll see I have all those files that were uploaded by the main account. And I can upload another file. And this will show up in the first account we created, and it will be listable by that initial account. So if I do W3 up list as the initial account, you'll see a new CID on that list. And what's that? Yeah, we've only ever uploaded to one account. So now I'm back acting as the main actor, listing my own account, and I can see the new upload that was just done. So I think that's the whole second challenge. This can be done in code as well. And on that page that's printed out, there's a link to this GitHub repo, which is like a function, an API endpoint that would give your end users access to your account. So thank you very much. We have a couple of little resources here for you.